Next we have the data lockout flip-flop. Data lockout flip-flop. Okay. When we discuss master-slave flip-flop, a serious limitation was that the data input should be held high, or held constant when the clock was high. Okay. Otherwise, if it's not held high, or if it's not held constant, unpredictable outputs may occur. Okay. In order to, I've already discussed, in order to solve or what we call rectify such an issue, we introduce the data lockout flip-flop. Okay, how it works? Let's discuss. The data lockout flip-flop. A severe limitation of the master-slave flip-flop is that the data inputs must be held constant while the clock is high, because it responds to any changes in the clock inputs when the clock is high. Okay. This problem is overcome in the data lockout flip-flop. A data lockout flip-flop has dynamic clock input. Okay, that is, what it does is, during the transition or during the application of the clock, the data will be locked. Okay, and further changes will not take place, and thus there will not be issues about change in data. Okay, thus it has a dynamic clock input, making it sensitive to data bits only during the clock transition. After the leading edge of the clock transition, this should be noted. Okay, after the leading edge of the clock transition, the data inputs are disabled. That is, no further changes takes place in the input, and thus not held constant while the clock pulse is high. Thus, the master portion of the flip-flop is like an edge-triggered device. Okay, and the slave portion performs like the slave in a master-slave device to produce a postponed output. So, from these two concepts, that is, master portion produces what we call, it acts like an edge-triggered concept, and also the slave portion produces output like a master slave, that is a postponed output. So, we need to understand that the logic symbol for this particular device will contain the edge-triggered clock symbol. At the same time, it also has the postponed output concept. Please go through. Thus we come to the end of this particular topic, master slave flip-flops. Okay, and this is the logic symbol for data lockout. Okay, master slave flip-flop with data lockout. So we have the J and K inputs, and the clock is given. Okay, we know what's the difference between this clock and the original master slave flip-flop clock. So we have a triangle over here that I have already said how that particular clock came. And also we have the delayed case, that is delayed output. Delayed output means it depends upon the slave of the master slave, and also the master works as the edge triggered, follows the edge triggered concept. Okay, so this is the case. We have the symbol also, that is postponed output. We have a triangle which shows that it's edge triggered. If there is no bubble also, it means it's edge triggered, positive edge triggered. We have the JK inputs and Q and Q bar outputs. Okay.